Hello everyone, welcome to my channel. I hope you all safe and doing well. Today we will dive into the fascinating world of quicksort. Quicksort follows divide and conquer algorithm. That means it divides the given problem into subproblems until the subproblems get a solution directly. This technique is divided into three parts: divide, conquer and combine. Divide means breaking down the main problem into subproblems, and conquer involves the solving these subproblems by using the recursive calls until each subproblems get a solution. The combination phase integrates the solutions from all the subproblems to get the final solution for the given problem. Let's see the advantages and disadvantages of divide and conquer algorithm. Divide and conquer is easy to solve the large and difficult problems. It divides the large problems into subproblems, thus it can be solved parallel. And this method reduces the time complexity. Then coming to the disadvantages, it may not be the most efficient algorithm for all the problems. And it's using recursive calls, so it may be difficult to find out the stopping conditions. This is a short description about divide and conquer algorithm. Now coming back to the quicksort. The name quicksort reflects its quick and efficient sort of the large given data. It follows in-place sorting algorithm. It means it doesn't use extra space to sort the given data. That means it produces an output in the same memory. And quicksort uses extra memory space only for recursive calls, not for input data manipulation. When considering the time complexity of quicksort, its average and best case time complexity is order of n log n. This makes quicksort highly efficient for large data sets. And quicksort may have worst case time complexity of order of n square, particularly when the input data is already sorted or it's nearly sorted and the pivot is consistently selected as the smallest or largest element. Well, now let's see how the quicksort is implemented. Let's consider this as the input data. So we have to sort this data using quicksort. Well, I need to do some initial setup. I will call this as low and this as high. Okay, now I will define start and end. This is a start and this is a end. Okay, now we need to define a pivot. Okay, pivot is nothing but a key element. Quicksort picks an element as a pivot and then it partitions the given data around the picked pivot element. Okay, how do we choose the pivot key? You can take any key from the given data as the pivot, or you can pick leftmost or rightmost, okay, or middle element as a pivot. There is no constraint in selecting the pivot key. So now I am selecting the first element as the pivot. Let's define the pivot key. Okay, so the pivot is 7, that means the 0th index. Now we need to find the proper place for this pivot in the given data. Keep in mind that this algorithm follows a divide and conquer strategy. So we have to start the data by dividing it in such a way that values less than the pivot are on the left side and values greater than the pivot are on the right side. This is called as partitioning. Partitioning is the backbone or the fundamental idea of this algorithm. Well, now let's determine the proper place for the pivot. If you find any element that is smaller or equal to the pivot, increment the start by 1. If you find any element that is greater than the pivot, then no need to increment this start. Okay, keep the start at the same position. Okay, let's do it. Now consider start is 7, okay, and pivot is 7, and the condition is like start is less than or equal to pivot. 7 is less than or equal to pivot. Yes, that's true. Then increment the start by 1. Now start pointing to 6. Okay, now start pointing to 6. This start is less than or equal to pivot. Yes, then increment the start by 1. Now start points to 10. Thus start is less than or equal to pivot. That means 10 is less than or equal to 7. No. Then keep the start at the current position. Now starts with the end. End points to 7. Okay, so in this case you have to check if the end is greater than the pivot. If the end is greater than the pivot, then decrement end by 1. If not, then stop the end at the same position. Okay, so I will repeat once again. If the end is greater than the pivot, then decrement the end by 1. If not, then stop the end at the same position. Let's check. If end is greater than pivot, that means 7 is greater than 7. No. Hence, stop the end at the same point. Now, swapping will comes into picture. Swap the start and end. Okay. Hence, we got this after first swap. Now, continue the same thing. Okay. Now, continue the same thing. Now, start is pointing to 7. Hence, start is less than or equal to pivot. Yes. Now, again increment the start by 1. Now, start is 5. Okay. And start is less than or equal to pivot. Yes. Again increment the start by 1. Now, start is pointing to 9. So, start is less than or equal to pivot. Pivot is 7 and start is 9. So, it's false. So, stop the start at the same position. Now, coming to this. Okay. End is pointing to 10. Okay. So, end is greater than pivot. End is 10 and pivot is 7. So, 10 is greater than 7. Yes. Hence, decrement end by 1. Now, end pointing to 15. Again, check the same condition. End is greater than pivot. That means 15 is greater than 7. Yes. Then again decrement the end by 1. Now, end pointing to 1. Again, check the same condition. End is greater than pivot. No. Then stop the end at the same position and swap start and end. Okay. So now after second swap, end is pointing to 9 and start is pointing to 1. And again follow the same steps. Start is less than or equal to pivot. Yes. Then increment the start by 1. Then start will become 2. Then now start is less than or equal to pivot. Yes. Then again increment by 1. Start will become 9. Now check, start is greater than or equal to pivot. So start is 9 and pivot is 7. So it's false. So then stop the start at the same position. Now compare the element with end. Okay. End is pointing to 9 and end is greater than pivot. Yes. Then decrement end by 1. Now, end is pointing to 2. Okay. So end is greater than pivot. No. So till now we are swapping this end and start. Okay. Okay. But now the start is crossed the end. Now that means start is greater than end. Okay. So in this case we will not swap start and end. Okay. We need to swap end with pivot. Okay. So after third swap, now pivot got the proper place in the given data. So this is partition 1 and this is partition 2. Now all the small elements are left side of the pivot and all the large elements are the right side of the pivot. Okay, well, we have divided the given data into two partitions. Now apply the same steps to each partitions. Take one pivot from this partition and start finding the proper place for the pivot. Take another pivot from this and start finding the proper place for the pivot. Repeat the same steps until the sub-problems are directly solved. Fine. This is all about the implementation of quicksort. Okay. Now let's see how we can achieve this by coding. Let's define a given data. Now I will write a function for partition. And it will expect 2 parameters. Okay, now we'll define the pivot. Pivot is equal to data of low. Okay, now we'll define the start is low and end as high. Okay, so now we start the looping. So what's our condition? Our condition is like start should be less than end, then only we will swap with start and end. Okay, start is less than end, and here again while loop, while data of start is less than or equal to pivot, then start plus plus. Okay, then what's another condition? If data of end is greater than pivot, then end minus minus. Okay, now we need to do swap. So I will write one condition: if start is less than end. Okay, so then that will define one temp variable. Let temp equal to data of start, and data of start is equal to data of end, and data of end equal to temp. Okay, so this is the code for only if the start is less than end. Okay, so if the start crosses end, that means start is greater than end, then we have to write one swapping, that is let temp. Now we need to swap end with pivot, right? So data of low and data of low is equal to data of end, and data of end equal to temp, and we will return end. Now you need to call this partition function. So for that I will create one function called quicksort. Okay, so this also expect low and high. Okay, around condition: if low is less than high, then we'll call this partition. What's the two parameters? Low and high. Okay, low and high. Okay, so this method will return the end. Okay, end means this is the partitioning position. Okay, so I will take this in position variable, position. Okay, so now we need to call this quicksort recursively. Quick sort low position minus 1. Okay, and quick sort position plus 1 high. Okay, so now we need to call this quicksort. Call quicksort. Low is 0 and high is data dot length. Okay, so I will print console.log print sorted. Okay, we'll run this one. Okay, this is the output. Let's trace this code. Okay, we have a given data. Okay, and we are calling one method, that is quicksort, by passing some parameters. Okay, inside that we have some condition. We are checking the condition, and inside that we are calling partition method, and recursively we are calling quicksort, same method, quicksort method. Okay, So what is low? Low is 0 and high means length minus 1 means 8. Okay, so 0 is less than 8, yes, then condition is become true. Then we are calling on partition method and we are passing this high and low, low and high. Okay, coming to this partition method, okay, the pivot becomes 7 and start become 0 and high become 8. Okay, we are checking the same condition, start is less than or equal to end. Then in this case it will become true because start is 0 and end is 8. Okay, then control comes to the inside this loop. Okay, now data of start means 7 and less than or equal to pivot means 7. Okay, now the start is initially 0 and now start will become 1. Okay, now again it will go to the same loop. Data of 1 means 6 and less than or equal to 7, yes, again it will become true and it will increment by 1, start will become 2. Okay, data of 2 means 10. 10 is less than or equal to 7, no, in this case it is false. Now the control will come out of this loop. Now control goes to this loop and data of end. What is the data of end? End value is 8. Data of end means 7. Okay, 7 is greater than 7, no, so this will also not executed. Now coming to this condition, start is 2 and end is 8, so the condition is become true. Okay, now we are swapping the data. Okay, so after first swap our data will become like this: 7 6 7 5 9 2 1 15 and 10. Okay, this is the first swap. Okay, now again our control will go to this loop and it will check. Start is 2. Okay, 2 is less than 8, yes. Okay, data of 2 means 7. 7 is less than or equal to 7, yes, then again data start will increment by 1, that will become 3. Okay, data of 3 means 5. Okay, 5 is less than or equal to 7, yes, true, then it will become 4. Okay, now data of start means data of 4 means 9. Okay, 9 is less than or equal to 7, no, this condition is failed. Now it will go to this phase, this loop. Okay, data of end, what is the end value? End value is 8 only. Okay, data of end 10. 10 is greater than 7, yes, now it will decrement by 1. Okay, that time it will become as 7. Now data of end, data of 7 means 15. Okay, 15 is greater than 7, yes, then again it will decrement by 1, that time end will become 6. And data of 6 means 1. Okay, 1 is greater than 7, no, this condition is failed. Now it will come to the if condition. What's the start value? Start value is 4 and end value is 6. Now 4 is less than 6, yes, then again it will got swap. After second swap we will get 7 6 7 5 1 1 2 9 15 and 10. Okay, this is second swap. Okay, now again it will go here. Okay, so what is the start value? Start value is 4 and end value is 6. Start is less than end, yes, then data of start, data of 4 means 1. Data of 4 means 1. 1 is less than 7, yes, then again start will increment by 1, then start become 5. Okay, data of 5, data of 5 means 2. Okay, 2 is less than or equal to 7, yes, then again start will become 6. Okay, data of 6 means 9. 9 is less than or equal to 7, no, then control comes out of this loop, then it will go to this loop. So data of end means data of 6. data of 6 means 9. Okay, 9 is greater than 7, yes, then it will decrement by 1, that time end will become 5. Okay, so data of 5 means 2. Okay, 2 is greater than 7, no, so this condition also failed. Now control comes out of this loop, then control go to this. Okay, so what is the start value? Start value is 6 and end value is 5, so this is failed. Okay, now it will go to this. Okay, so what's the start value? Start value is 6 and end value is 5, so this loop is also failed to execute. Now it will come to this. Okay, so again here we, okay, in this case, see, start is greater than end. Okay, so if start is greater than end, what we have to do? We have to swap end value with pivot. Okay, so after this we'll get a partition position we'll get. Okay, so I will add some console logs here, so you'll get better. After partition and console log after swap. Okay, yeah, see, this is the first swap and this is second swap and this is the first partition. Okay, and this is the swaps after the partition. Again it's calling recursively. Okay, until we get the sorted data. Okay, yeah, so this is all about the quicksort implementation. Okay, so let's consider when we can use this quicksort. We can select the quicksort over other sorting algorithms if we have a large data set and we don't want to use extra space of memory to sort the given data. Okay, and coming to the real-time examples, quicksort is using in large database managements, and many programming languages or libraries uses quicksort as their default sorting algorithm, and many search engines uses quicksort, and many e-commerce applications uses quicksort to sort their products. Okay, coming to the conclusion, in this session we have learned about quicksort implementations and quicksort uses and quicksort examples, and also we have learned divide and conquer algorithm in detail. Yeah, this is all about the today's session, that is quicksort algorithm. Okay, thanks for watching. We'll see you in the next session. Till then, thank you. Bye bye.